Hello, this is Scholar Strife doing some math. Today we'll be in Algebra II, working with, what's the name of this? Evaluating nth roots and using rational exponents. Okay, so this is kind of be review, because we're working with square roots again, and we're going to be simplifying them, multiplying, working with them. But this time we're going to have not just squared terms, but we're going to have, or square root terms, we're going to have nth root. So the nth root of a, so we're going to have b to the n power equals a. That means b is the nth root of a. So that means we got this going on. So index, so if we have something that looks like this, n is the index. So powers and roots are equivalent. What we mean by that is if we have a to the 1/2, that is the same thing as the square root of a. A to the 1/3 is equal to the third root of a. A to the 4th equals the 4th root of a. And a to the 1/2 to the squared is the same thing as a 1/2 times 2, which is a to the 1st, which is a. So all our properties still apply. And then on the right side here, we have a list of cubes and fourths. So for example, 2 to the cube is 8. So, for example, if I wanted to say what is the cubed root of 8, that would be 2. Okay. And then we have the fourth root. Fourth root of 81 is 3, and so on and so forth. So what you're doing is, before we use these to help us when we're breaking down a square root, we looked at certain factors and we want to look at perfect squares. Now here are the perfect cubes, and here are the perfect quads, whatever fourth is. So here we go. Let's do some examples. Let's get rid of all those letters. Here we go. So cube root of negative 216. So I'm going to go up here again, and I notice that cube root, that's 6 to the 3rd is 216. So I'm going to have, this is the same thing as negative 6, 6, 6. Oh, wait. That's not the same thing, because we're doing with cube roots. So where's my eraser? There we go. So, and it's negative. So negative 6, negative 6, negative 6, that equals 216, or negative 216. So the cubed root of negative 216 is equal to negative 6. Okay. Let me fix that a little bit. Okay, next problem. 54. Let's break that into, so now we're trying to break it down into cube roots. Before we were looking at square roots, so we're looking for perfect squares. Now we're looking for these numbers here. Okay. So 54 breaks down into negative 27 and 2. So what's going on is we have the cubed root of negative 27 times the cubed root of 2. So the cube root of negative 27 is here. We have 3 to the 3rd power is 27. So negative 3 to the 3rd power is negative 27. And then we have cubed root of 2. So just like our square roots, doing the same thing, we're just using, instead of perfect squares, you're looking at perfect cubes and perfect quartics, or whatever the fourth is called. Okay? So fourth root of 32. Okay, so now we're going to be using the second column here. So this is fourth root to the 16 times fourth root to the 2. So I just broke 32 down into 16 and 2. So fourth root of 16 can be either plus or minus 2. Okay. Now the reason why it's plus or minus is because we're working with evens here. And if you notice, negative 2 times negative 2 times negative 2 times negative 2 is positive 16. And so it is, of course, 4 positive 2's make 16. So we're left with that. Okay. Number 4. Fifth root of 32. Now, if I made a list of fifth roots, you would notice that 2 to the fifth is 32. So this is just 2. Okay. So let's look at more of these properties here of nth root of a. So if it's the nth root, is even, and a is less than 0, so the number under the square root is negative, we have no real roots. Real roots will have imaginary numbers. If a is equal to 0, then there's one real root. And then if a is bigger than 0, there are 2 real roots. If n is odd, like third root, fifth root, seventh root, and a is less than 0, we have a negative number, it implies there's one real root. A equals 0, there's one real root, and a is greater than 0, there's one real root. So if n is odd, we'll always have at least one real root. Or there is one real root. So let's do another example. Excuse me. Here we go. So we have the third root, n equals 3, of negative 729. Okay, so if we look back at our chart, a is less than 0, that means it's negative. There is one real root. So, and that happens to be, if I look back at my chart, 729. Okay. Now, are we going to memorize this chart? No. We can use a calculator to help us do this. For example, if we have, I think if I look at a calculator, let me see, calculator. Hopefully it's still open. Here it is. If I look at this calculator here, I am looking for, oh, this one doesn't have it. Well, if you're using a graphing calculator, it'll be under math, and then you have x root here, and then it will let you type in the root. So, for example, third root of negative 729, boom. If you have standard calculator, there will be this symbol here. And what you want to do is type in your nth root first. So the x value there, you would say, you would type in 3. And then this button here. And then you type in whatever's under the square root. Alright, let's go back. Back, I say. Okay, going back. So once again, my chart tells me that 729 is 9 to the third. So this is negative 9, negative 9, negative 9. So Oh, well, yeah, this is equal to negative 9. Done. That's my one root. Okay, now my nth root is even. 81. Look at our chart here. Boom, 3 to the 4th. And since this is even, and so the n is even, greater than 0 means 2 real roots. We have plus or minus 3. Those are 2 real roots. Okay, let's move on to the next page. Interesting. Clouds, lightning, different bubbles. Okay, anyways. So what if we have something to a fraction? In the numerator, that will be our power. Like 3 to the second power. But if we're doing a fraction, so the power is in our numerator, and then in our denominator, we have the root. So for example, we have a to the m to the n, or no, a to the m over n power. So the m gets attached to the a, and then we take the nth root. Okay? Alright, here we go. Oh, and if we're using a calculator, so again, once again, this is my root, this is my power, and if we're using a calculator, just use caret. You know, just 2 to the 2/3. So 2 caret 2 divided by 3. Make sure it's in parentheses. So here we go. 16 to the 3/2 is equal to the same thing. So my bottom denominator is my second root of 16 to the 3rd power. Okay? So my second root is the same thing as square root. What is the square root of 16? 4. And then we still have the 3rd power there. 4 to the 3rd power is 64. Done. Number 2. 32 to the negative 3/5 power. Okay? Now remember, whenever we have a negative exponent, we have this rule where we flip it over our fraction here. So 1 over 32. And then we make the exponent positive. So this is 32 to the positive 3/5 down here. Okay, so that's the same thing as saying 1 over 5th root 32 to the 3rd. Which is the same thing as 1 over the 5th root of 32 is 2. And then we have 2 cubed, which is 1 over 8. And yes, I do want it in fractions. So 125 to the 2/3 is the same thing as the cubed root of 125 squared. Cube root of 125 is 5. And then 5 squared is 25. Let's do more. 4x to the 5th. So now we're working with equations. So 4x to the 5th equals 128. So the first thing I do we're just getting x by itself, divide by 4 to both sides. So x to the 5th equals 128 divided by 4, which is 32. And then we're going, the opposite of putting something to the 5th root is to do 5th root of something. So I get x equals 2. Number 2. So we have x minus 3 in parentheses 2 to the 4th plus 4 equals 21. Trying to get x by itself. So I'm going to move 4 over, get x minus 3 to the 4th equals 21. And now I'm going to take the 4th root of both sides, because I can't do anything in the parentheses there. Okay. So this is going to be x equals x minus 3 equals plus or minus 4th root of 21. Now there's nothing we can do with 21. That breaks down into 7 and 3, and none of those are perfect quartics. I really need to look at that up. So, and then the reason why it's plus or minus is because we have an even root. So 4 is even, so it can be plus or minus. So last thing to do is add 3 over. So I have x equals 3 plus, whoa, where'd everything go? Send it back, please. 3 plus or minus the square, 4th root of 21. And that is 2 real roots. Alright, let's keep going. Well, 6x to the 4th minus 1 equals that big number. Okay. 6x to the 4th. I'm just going to add the 1 over. I get 1536. And now I'm going to divide by 6 to both sides. Hopefully you are using a calculator. This becomes 256. And to get rid of the x to the 4th, I'm going to 4th root both sides. And because I'm doing that, I'm going to get a plus or minus. And then I'm going to check my chart here. Oh, from the first page. Boop. Right here. 4 to the 4th is 256. So the 4th root of 256 is plus or minus 4. Alright, one more. So first thing I'm going to do is subtract 1 from both sides. So 5 times x minus 7 to the 3rd equals 1875. Divide everything by 5 now. So I get x minus 7 cubed equals 375. Now I'm going to do the cube root of both sides. So this one's not as nice. But we're going to look at our chart here and see what 375 breaks down into. And we will notice, so here's x minus 7 on that side. And we notice that it breaks down into 125 and 3. Okay. So this is going to be x minus 7 still. Cube root of 125 is 5. Oh, that's equals. Let's erase that. Okay, 7. X minus 7 equals 5 cubed root of 3. Okay. And then lastly, x equals 7 plus 5 cubed root of 3. Alright, let's do one more practice problem. A study determined that the weight W in grams of coral cod in the Philippines can be approximated by W equals that mess to the 3rd power, where L is the length in centimeters. Oh wait, oh that was an L, okay. 0.0167 L cubed, where L is the length. Estimate the length of coral cod that weighs 200 grams. Okay, so we have the formula there, and they said W is 200. Find L, so 200 is 0.0167 L cubed. So the first thing I gotta do is divide by the 0.0167 to both sides. Come on. There we go. And then you should get 11,976 equals L cubed. And then we take the cubed root of both sides. And then use our handy dandy calculator. And I guess I might as well show it since I still have it up. Boom. Whoppa. Oh, look, they have a cube root button. Cube root of 11,976. Enter. 22.9 or 88. Yeah, let's go 88. And then okay. Nope. Our answer is 22.88. And since we're dealing with length, centimeters. So, the length of so if we have a 22.88 centimeter coral cod, and then it'll weigh around 200 grams. Okay. That's it. We're also going to look at some interval notation. So I'll help you out with this worksheet here. So we have the inequality. -4 less than or equal to x, which is less than or equal to 10. That is the same thing as x is between -4 and 10 inclusive. Inclusive means it includes -4 and 10. If they didn't have the greater than or less than or equal sign, then I would just say x is between -4 and 10. And then the interval notation, we're going to do bracket. Bracket means includes -4, and then a comma, it goes to +10 and includes 10. And then graphically, we have -4, we have 10. And then we shade in between. Oh, close dots, because they're greater than or equal to. Alright, let's do another one. So interval notation, they have a bracket on -3, comma, and then infinity parentheses. Okay? So what that means, x is greater than or equal to -3. Okay? And to say it again, x is greater than or equal to -3. I don't have enough space to write it clean, but hopefully you're listening to this. So we start at 3, or here's -3, and again it's a solid dot, and we're just going to go to infinity. So the next one, x is between 10 and 25. So inclusive, which means we have x here, 25, 10. That means 10 bracket, 25 bracket. 10, 25, both solid dots in between. Now infinity. How would you write this? This would be all real numbers. I guess the inequality would be I mean, you could say x is greater or equal to 0 and x is less than or equal to 0. I don't believe you can say negative infinity. I don't believe you can say that, but it doesn't matter. Whole thing shaded. You know what from negative infinity to infinity looks like. X is greater than negative 2. Well, that's easy to write. X is greater than negative 2. So this one, our lowest point is negative 2. And we're going to have a parentheses because it's not including negative 2. And it's going to go to infinity. So we have negative 2 here. It's going to be an open dot. And then we shade to the right. X is at most 15. Which is the same thing as x is less than or equal to 15. This one, we can be all the way down to negative infinity. And then at most, 15 is a bracket. So we have 15 here, solid dot, shade all the way over here. Let's do something. Okay. X is at most 5, but greater than negative 3. So negative 3 is our lowest point, but it's not equal to, so we use a parentheses. And then we go to 5, including 5, so we use a bracket. So we have negative 3, and then we have 5, open dot on negative 3, solid dot on 5, and then shade in between. And a lot of these are the same. Trying to look for one that's different. This one on the bottom here is just written kind of backwards. It's just saying x is less than 8, but greater than negative 2. You could say this x is in between 8 and negative 2. That's the same thing. So this would be both parentheses because they're not touching negative 2 or 8. The words are x is between those two numbers. And then we have negative 2, 8, open dots, shaded in between. Is there anything else that's different? X is greater than 0, but less than or equal to 10. No, that's not. Oh, here we go. That's different. Okay, so I'm going to look at the third one here. That one that just gives us the graph here. Negative 15, negative 14, negative 13, negative 12? I think it's negative 12. So that one's a little different because we're starting with the graph. Our lowest point is negative infinity, and then our highest point is negative 12, including because it's a solid dot. So that means x is less than or equal to negative 12. I'm not going to write it in words. I just said it. Okay, next. Here we go. The next graph, right here. So this one we're going to have two intervals. We're going to have negative 6. So lowest point is negative infinity. And then it goes to negative 16 inclusive. And then we're going to write U for union, which means or in this case. Lowest point on the right side is 2. It includes 2, and then it goes to positive infinity. There we go. That's how you write that one in interval notation. This is the same thing as saying x is greater than or equal to 2. And at the same time, it is less than or equal to -16. That's how you write that one. How would you write it in words? I would say x is less than -16 or greater than 2. Okay, let's look at some other stuff. Here we go. The word x is between 3 and 6 exclusive. That means x is... Oops. X is between 6, so less than 6, but greater than 3. No equal to. So I have parentheses on 3, 6. So here's 3, here's 6. Open dots shaded in between. Okay. And everything else looks... I feel like I've done enough examples. Alright.